Hello there, and welcome back to Small Lang, the programming language that you build yourself. I'm hoping that this would be the first programming language that you build with the guidance of these videos. Yeah, so this is part 2 of the series. In part 1, we built a lexer, which is able to go through all of this program, lex this file, that's the proper verb for this, and convert this input as a string into a series tokens. What do the tokens look like? Well, they look like this. Each token is an object with a type identifier and a value. And the type identifier sort of give you like a tag for what type of thing this is. Like a right parenthesis is an R-paren. A number is a number. And an identifier is a word like fib. So you can see that, oh, this is an identifier, this is an assigned token, this is a left paren, this is another identifier, and so forth. It has grouped your strings into these small chunks of strings, and these tokens are the things that we're going to be feeding into our parser, which is what we're going to make in this session here. More specifically, we're going to start building our parser to the point of being able to parse a statement, a variable assignment statement like this. So let's go ahead and get started. We're going to be using Nearly.js to do this. This is Nearly.js. In my series on how to make a programming language, I actually have quite a bit of detail explaining how to use Nearly.js. So if you are wanting more details about this, then go check out those videos. Here, we're going to make a grammar that is able to parse this. So I'm going to call that grammar file small.ne. Small is the name of our programming language, and ne is a shorthand for nearly. Okay, and in this grammar file, we're going to write a set of rules, and we're going to define what a statement is. And at the moment, since the only thing we're trying to match is a variable assignment, I'm going to say a statement can be a variable assignment, a var assign. Now I'm going to define what var assign is. A var assign is first one of these. What is this? This is an identifier. If you have a name that's not been quoted, that's an identifier. And then we're going to have some optional white space. In Nearly.js, they recommend you use this convention where optional white space is signified using a 1 underscore, and a mandatory white space is signified using 2 underscores. We have an assign operator, which is that. You can either identify the assign operator using this % sign before the name, the type of the token, or if in the case where the string is going to be always the same string literal, you can actually just name the string literal surrounded by double quotes, which is what I prefer to do in the case that I can do it. With the identifier, I can't do that. Actually, I made a mistake before. This identifier needs a % sign before it. Haha. Oops. To identify a token, you can either identify by the type, in which case you need a % sign before it, or identify it by a string literal, which is possible if the string that's matched is always going to be the same string. Well, okay. There are some cases where you can use the string literal to match even something where the right-hand side of this can change. But we're probably not going to do that in our language. Variable assignment is going to start with an identifier, optional white space, an assigned token, optional white space again, and then some expression, which could, at the moment, it could either be a string or a number. So let me define something that's called an expression or expr. And I'll say that an expr is either a string token or it can be a number token. So vertical bar is how you notate the or in Nearly.js. So with this grammar, I think we're actually able to build a parser, probably. Let me try it. Nearly C small.ne, and we'll have it output a file that's called small.js. Oh, I forgot to define this optional white space, so let me go ahead and do that. I'm going to say optional white space is one white space token, which was defined here. Actually, 0 or more of them. If I use colon and then the star, this star symbol works just like regular expressions. This means 0 or more of the thing before it. So this is 0 or more white spaces. If I want to define a mandatory white space, I would do this. I would say 1 or more. The plus sign means 1 or more of the thing before it. I'm gonna try to generate my parser again, and it did it. We have a small.js, which looks like this. Usually you're not looking in this file, although there are some cases where you might want to actually debug the contents of this file, but usually not. We have a grammar that nearly is able to understand now, but we'll still need to make tweaks to this guy. Now I want to actually copy this command out and put it in our package.json. I'm going to delete this test because at the moment we don't have tests yet. I'm going to make a script called genParser, and I'm going to paste this nearly C command that I used to compile this nearly file into a JavaScript file, put it into this genParser script so that later on I can say npm run genParser and it'll do that for me rather than typing in this long old thing. So anyway, now we're going to use the output of this guy, this small.js. We're going to use it to actually parse a file such as this one. Let's go to nearly.js and go to their getting started guide. This is how I always do it because I still don't have this memorized. So I'm gonna make a file called parse.js and paste this in. This grammar is gonna come from our small.js, which we just generated. Nearly, that stays the same, and now we're getting a parser. I'm gonna feed the code into it. After feeding the code into it, the parser, if successful, will have some result, and we're going to print that out. At this point, I actually want to write some code that will allow this to read in a file from the command line, run it through this parser, and then spit out another file, which is a JSON formatted file that contains the result of the parse, which will eventually become our AST, aka the abstract syntax tree. Okay, so again, I'm going to use the MZ library to allow us easy access to the file system, and I will write code in this async await manner using async functions, like so. Now we're going to read in the code. Let's grab the file name from process.argv index2. Why index2? Well, if you run this command node parse.js, say ex1 small, well, node is going to be index 0, parse.js is going to be index 1, and ex1.small is going to be at index 2. That is why index 2. And we're going to say, well, if you didn't give me a file name, please provide a .small file, and we will return out of here. But if they did provide one, we're going to read that file in. Here's the code. Await the result of fs.read file, that file name, and convert this buffer to a string. There's our code. We're feeding it into this parser. Let's print out the result for now. Okay, there is a result. It says identifier is not defined. Oh, I forgot an important step. I forgot to plug in my lexer into my parser. Let's go ahead over to our Nearly.js website. Part about tokenizers, how to have Nearly.js interact with Moo. And the way you do it is you put this chunk of code at the beginning of your parser, and then you plug in your lexer this way. This lexer is going to reference this variable. You can actually call this variable whatever you want, and then you can call this guy whatever you want. You could basically you could take this chunk of code and paste it in your parser here. This block of code has to start with at, open curly, and then %, and then you close it with % close curly. I don't actually want to paste in the code for my Lexer here. I want it to stay in my Lexer.js file. So I'm going to change this Lexer.js to be more of a library instead of a script. So this main function, which I called, I'm not going to call this main function anymore. And instead, I'm going to export this Lexer out to a calling script by doing module.exports. This is common JS style of exporting an object from a file. I'm going to export this Lexer object as the default export using this syntax, and then actually this parser file is able to require it. So we have the Lexer in a variable now. Now we're able to use this syntax, this add Lexer syntax, to plug in this Lexer. So this Lexer is referring to this Lexer. You could call this something else, like my Lexer. And that should work now. Previously, this totally bombed because I forgot to plug in my Lexer. And now, if I did it right, it should work. So, but in order for it to work, I have to recompile, regenerate my parser. Now let's parse it. And now we have an actual working result coming from the parse, which is actually really great. But we can't sort of see all of the details within it. Let's do this. Let's print the output into a JSON formatted file suffixed by .ast. I'll make a variable called output file name. To get the output file name, we'll just replace the .small with .ast. So given a .small file, we'll generate a .ast file. There's a possibility that the parser could give you multiple results, which will make the grammar an ambiguous grammar, and that's usually an undesirable thing. We're only going to pick out the first result, and then we're going to say if parser has more than one result, that's actually a problem. And I'm gonna, for now, I'm just gonna say error, ambiguous grammar detected. It's actually helpful to have a record of all the results to debug the problem when there's an ambiguous grammar, but I'm gonna save that for later. For now, I'm just gonna say error, ambiguous grammar detected, and then, but I'll say else if parser.results.length is 1, then this is perfect. Then we just have one result. We'll call that guy the AST, and we're going to save it into this file. Let me grab this line and put it in here, and then say await fs.write file, output file name, and then json.stringify. So JSON stringify, if you want it to format the string with some indentation, this is what you do. The second argument doesn't matter, you just give it null. There's actually a rhyme and reason for the second parameter, but we're not using it in this case. And then else, if parser doesn't give any results, which that actually means the parse has not completed. Maybe the parser is in the middle of finishing the parsing of a program, but the program is not complete. So here I'll just say error, no parse found, and that's what I'll say. Oh, and after writing the file, I will want to print out wrote and then the name of the output file. So I believe that is our parse.js. Let's try to run it. So I did write ex1.ast, and that's our output. It contains each token that came from the Lexer, and it's sort of collected them and put them in various arrays. And that's what we're seeing here. We have some white space tokens here. We have an identifier token, and we have a sign token, which makes sense because there was an equal sign, another white space token, and then a string, which also makes sense. Now, our job is to update our grammar so that each of these production rules sort of returns a clean object that represents that syntax element. And we're going to call these things AST nodes. How do you do that? First, let me say something about how Nearly.js sort of packs these tokens in and returns them back to you. So whenever there's a rule and Nearly.js matches that rule, like it finds something that satisfies this rule. For example, expr. It's like, oh, I found a string token, so that matches expr. It takes the right-hand side symbols, or in this case, there's only one single symbol. It doesn't matter. It takes each thing in the right-hand side and packs it into an array. Let's say the string was Jackie, and it has type of string, right? So this guy is the token, and it is a string token. It's gonna stick it in an array. Because who knows, like there might be more tokens. As in is the case with this one, there's actually 5 separate tokens. I'm going to pack it in an array and pass it into the next level. Attach this array to the var assign, and then at the next level, this var assign will be wrapped inside of another array again, which means we'll actually get an array that contains this array. And this array will actually contain bits from lower down. Like this is a white space. Oh, there's an array here, so this guy goes into here, and as well as here, and then this guy, since this comes from here and this is packed into an array, we just have many levels of nested arrays. To sort of get out of these like very tedious packing of symbols inside of arrays, what you do is write a converter like this. You can write it in JavaScript. I usually like to use a arrow function syntax, although you can use normal functions as well. Your converter function will take in a data, which is this array. So in this case, you're going to know, oh, this is an array of one element because there's only one symbol to the right hand side of this rule. If I want the first thing in the array, I will say data index 0 gets me the string, right? So if you want the expression to represent just this string and not have to wrap it into an array, you would say return data index 0. And presumably, I would want to do that for number as well. And actually, for most of the cases where the right-hand side, there's only one symbol, you would want to do this. So this is such a common case that Nearly.js supplies a shorthand for this, which is the ID function. This is like, don't change anything, the identifier function. It kind of has that feeling of just like, whatever that is, pass it on. So that's what I'm going to do. I'm going to slap this little thing at the end of each rule, well, most of the rules, where the right-hand side is just one symbol. Okay, so that's done. But for this case, it's not true that the right-hand side has just one symbol. It actually has 5 symbols. So in this case, I'm going to have a more custom function that will return an object that, to me, properly represents what this is. And what I want to represent a var assign as is an object that has a type identifier that says var assign, and it tells it like what is the name of the var variable. I'll call it var name, and it also has the value to be stored into that variable. Now, how do I get the var name? Well, remember this guy is an array with 5 elements in it. So if I want to get at this guy here, well, I want index 0. This is 1, this is 2, this is 3, and this is 4. So to get at this guy, to get the value I would want index 4. So what I want is data index 0 and data index 4. Okay, and at this point, I pretty much have a converter for every symbol except for the white spaces. And for the white spaces, I don't care because I'm not getting information from the white spaces anyway. So I'm going to leave those guys alone. I'm going to regenerate the parser. And I'm going to run my parse script again. And it will regenerate this .ast file. Let's look at what it looks like now. Now it says the top level is an object which has the type of var assign, and it has a var name of which is an identifier whose value is name, and its value is something of type string, and its value is Jackie. Cool. I'm going to conclude this episode here. We've built a parse.js script which is able to parse this first example program.